Hi guys, welcome back to my channel. Today we're going to be looking at different kinds of vectors which can describe motion. So say for example we were looking at the position of a particle from the origin. So we can represent this using either a series of vectors like this, or we can represent it using the Cartesian path. So here we can see if I was to try to find the rate of change of the position, so that is I was looking at the distance over a particular amount of time, I would be looking at the derivative or the rate of change. So for us here, when we're looking at the change in position over time, that is going to give us our velocity. So here would be a plot of the velocity, and we can see that this makes sense because gradually we are increasing the position away from the origin. Now let's have a look at our velocity here. So as we can see, with our velocity, this is just a straight line. So what if instead of finding the rate of change of the position, I now want to find the rate of change of the velocity? Well, the rate of change of the velocity, we can see it's pretty constant here. It's going up by a constant amount each time. So if I was going to plot the rate of change of the velocity, that would actually give me the acceleration. And we can see here that value for the acceleration is constant. So here we have all three. So in our red, we have our position or our displacement vectors. In our blue, we have our velocity vectors, and in our black, we have our acceleration vectors. So we can use differentiation to switch between each of these three. Now, if I was just given the acceleration and I needed to work backwards, well, rather than differentiating, I could integrate to find the velocity and then integrate to find the position vector instead. So let's have a go at this. Let's have a look at a real life question. Okay, so my worked example today, the velocity vector. So we're having a look at this piece of information right here. And we are given the velocity vector RT is equal to 2I plus 60j when t is greater than or equal to 0. So we need to find the position vector at any time t. So in other words, we're looking at finding the displacement. So we need to integrate to do that. So when we integrate this function, or when we integrate this vector, what we're going to do is we're actually going to integrate each of the components independently of each other. So the first thing I'm going to do is I'm going to look at integrating the x component. So I'm just going to do this off to the side here. So for my x component, I'm just given the value 2. So when I integrate this value, this is just going to become 2t because we're integrating with respect to this value t here. So now same thing with the y. So looking at the y component, we have that y is equal to 6t. So I'm going to use my power rule here. So I'm going to raise this t by 1 power, which will be 2, and then divide the whole thing by the new power. So that's just going to give me y is equal to 3t squared. Now, I bet you're thinking, okay, so we're integrating, where do we add the constant value at the end? Well, we can add that at the end as a vector. So we can write this now as RT. So since we've integrated once, we lose our little dot here. So this becomes 2ti plus 3t squared j plus our constant vector. So looking at the question here, they give us some additional information. So they tell us that when the value of the displacement or position vector where t is equal to 1, then the vector is equal to 3i plus j. So substituting into my formula here, I have R1 is equal to 2i plus 3j plus my constant. So now all I need to do is just substitute and rearrange. So 3i plus j is equal to 2i plus 3j plus c. So now we just need to rearrange. So 3i plus j minus 2i plus 3j will be equal to our constant c. Alright, so rearranging, 3 minus 2 gives us 1i, and then 1j minus 3j is going to give us negative 2j. So here we have the value of our constant. So we can go ahead now and we can rewrite that back in with our original equation. So to do that, I'm going to equate the two I components together so that I have RT is equal to 2t take 1I. And then I'm going to do the same thing with the j components here. So this is going to be plus 3t squared minus 2j. Alright, so that's how we use integration to find different motion or different vectors of motion. And remember, we can do any of these by either differentiating or integrating depending on what we are trying to determine and what information that we're given in the first place. Alright guys, that's it for today. I'll see you in the next one.